Hello and welcome back to the Power Shed. It's the new 2020 season, and last year I talked about I got these ELITECH RC-5s, and I went and extended out the wires so I could have a remote sensor, because when you're sensing water temperatures at 130 degrees, you don't want that sitting next to your lithium battery, because you'll get shortened life. But I thought that I could make these into some kind of data logger, and so this year I had a little problem. I had a pump that wasn't working, and I found the relay was bad, and I went to a MOSFET to turn it on and off. But I had no verification of whether the thing was working or not, because, you know, it used to be you could hear a clunking of the relay when I was in here, and now it was silent. And I thought this is a good time to, build a data logger. So this is what I've done, and what we do is we simulate a temperature sensor, and these temperature sensors are normally about 100K at, 75 degrees Fahrenheit. And so I have these two resistors in series, and that simulates the 75 degrees. And these temperature sensors are negative, so that means that the resistance goes down as the temperature goes up. And so I have a LM393 comparator here that has an open collector output, and I just short out one of the resistors, and that makes it go from 75 to 100 degrees Fahrenheit. And it's easy to see. I could make it go down to 0, which would be about 820K for this low resistor, but that much resistance, it makes this very prone to noise and things, so I prefer having a 47K here or lower even. So that's what I do, and the thing will chart. I run it off a 9-volt battery. The one I have here actually runs off 12 volts. Here's my little sense resistor, and here's the 393, and there's a couple extra parts to filter the 12 volts down. But this circuit only draws less than 2 milliamps, so if you have a 9-volt battery, or even an old lithium battery that's 4.2 volts, that will work. You just have to change the voltage divider a little bit. And you can use one of these nice expensive sense resistors. This one in particular is 50 amp, and it's 75 millivolts. So that means I got about 13 millivolts here. So you're going to need 10 amps to turn this thing on if you have this resistance shunt. But like I said, my pump is only about 3 amps, and so I just use a little length of wire. This gets me about 30 millivolts, so it's turned well on. There's two comparators, 1 through 3 pins. You just short the ground. It's the safe thing to do. Pin 4 is the power, negative, and 8 is the power positive. You have this little voltage divider, 22K down to 33 ohms. It's hard to imagine you get any voltage at that. But yeah, you get the around 13 millivolts. And if you wanted to put a pot in here and drive the pin 6 with the signal, you could adjust it down. These comparators have a 1 to 2 millivolt offset, so your numbers can be off too. They can even go up to 5 millivolts and still be within spec, but typically 2 millivolts is normal. So if you are measuring something which is just 3 amps, you're really going to be down in the soup. You're only getting out of this just under 5 millivolts. So you want to keep your numbers up at least over around 10. So what you can do is, if you want to make this multi-purpose, you have this big sense shunt right here. And then what you can do is add another extra resistance here, and so for lower currents you'll develop more voltage. On the negative side, the power comes in and goes to the load, and this is low side sensing. But you know, everyone hates low side sensing because you don't hook things up that way. You know, you like to run a common and negative. So actually this side over here, if you're running with a battery, you can connect this to the positive terminal, either the low side or the high current side, and this goes to your load now. So this would be positive. I don't know if you can see this. The batteries are about dead on this. I've had it over a year. Yeah, but it's still recording. And so there's the circuit. Let me show you what the graphing program does. So we're back, and this is the graphing program. You just plug that little sensor into the USB port, and it'll load up the program. You hit graph, and you get this nice little graph going across. As you can see, the pump comes on at random times. I have it timed to come on several times a day, and it checks to see if the voltage is over 14 volts, and then the pump will turn on. So sometimes it will run, sometimes it won't. You'll see it's a little bit random spacing. Now one nice thing is if you hit this right arrow, you can actually see the numbers. And so right here, for 4 minutes, we have 101.3 degrees Fahrenheit. So that means it's on. The rest of the time it's 75.9. Really nice. And we can go back. And this cursor, there's a cursor here. Yeah. And I don't know if you can see it, but there's this little red line. And you can put the red line anywhere. And it gives you the data point, the exact time, date. I mean, this is fabulous. But that's all you need. And this can be very useful. I'm thinking about another idea for this, but you know, if you want to see when your solar panels are producing over 5 amps or 4 amps or something like that, you know, you could put this in series with the lead, and you could get an idea of where your real power is during the day. But use your imagination. I think this is a easy little project. These are easy to modify and quite useful. And like, you get all this data stored for you, and it's right there, and it's accurate. I actually never knew that my pump only ran for 5 minutes. I was thinking it was 10 minutes. Things you learn. Thanks for watching.